It like fuck, like that means you're dealing with like when you get down to like like W over L equals
We could, no, we'll take care of that.
like that shit. I love that.
Okay.
I haven't really looked at it. Yeah, it's a good call. I didn't do it. Like, this could be
Like,
part of the signature.
no, it's just disappear after.
Yeah, I mean, the original was not.
All right. Sure. No. 303 as a person and then for the last project. But
Oh.
I didn't read it. And then
I didn't print out for 2 hours, but it said provide a range.
yeah.
That's part of the problem. That's about why it's my email. I know. It says like a range of and so I guess it's like not valuing anything smaller. It's not clear you get all you get high number that. So I guess it's like a second.
You only remember your last password.
I won't do that. None of every question.
Yeah. So I'm just switching between two passwords. Really?
So it's definitely, it definitely has for a range.
That's stupid. Yeah, no, every time I put, like I've had to just switch between two passwords every time it has to be.
Oh, yeah, I would just do this in non.
Yeah.
So the open loop gate of because of separate capacitor, it's easy.
Yeah.
We want to pass. It's this before. Oh my God. Let's see. We want to. So, yeah. And there's just input resistor. Obviously. So you know what's one.
Okay, hello everyone. Welcome to our lecture today. I have uploaded the lab 2 files. So we in next Monday we will have our second lab.
School next Monday. Yeah.
Yeah, so we'll do it in 3 weeks.
That'll be the book room.
Oh my God. So in next week it is long weekend.
Yeah.
So it will be after 3 weeks.
Yes. Yeah.
Let's spend 3 weeks in the book room, right? And we'll have to wait 4 weeks.
No. That's
No.
3 weeks. Because
Well, like the next week will be booked.
yeah.
Yeah.
So, okay, so I guess the week after.
Mm.
Is that gonna work? Like with our?
Okay, so you have long time to do lab 2, so I expect from you the full mark. Yeah, so it's already uploaded. It is about routing. Okay, so have a quick look on this file and try to figure out how to solve the pre-lab and how to implement the required MATLAB code. Okay, so okay, this is the lab 2 file.
Still do next week then, or is it going to be next?
It will be no. I think as in the next week will be a holiday. It will be next. Yeah.
Oh, we never read it this year. Oh, like that's the first one.
So we don't have a lecture.
Is that gonna make like the end really condensed? Like if we don't have a lab till 3 weeks from now, are we like if we have 5 labs, are we gonna be having like a lab during week 10?
Okay. Oh, do you mind? Do you mind if we have a lab within one of the lectures of the next week? Maybe on Wednesday, for example.
No, that's next week. That's probably better.
Yeah.
Yeah.
Okay. At the same time of the lecture. Okay. Okay. I will discuss this with Omid, your TA, and we'll send you an email about this. If we will have a lab during one of our lectures next week or not. Okay. Okay. So let's start our lecture today. our topic today is about automatic repeat request or automatic repeat query. In this lecture, we want to introduce the importance of automatic repeat request in communication networks. We want to describe 3 automatic repeat request schemes: stop and wait, go back in, selective repeat, and we want to make performance analysis for each scheme of the automatic repeat request. Okay, so let's have a discussion. What do you do when you can't hear someone? It's a survey.
Ask for repeat.
Ask for repeat. Okay.
Pretend like you heard them. Yeah.
So you will tell him, please repeat again, or what? Or what will you say?
Yeah. Say it again, please.
Retransmit. Okay, that's good. So yeah, we have different ways to ask him for repeat. What did he say? So I can tell him, I can't hear you. I can move closer to him to hear him better. Okay, I can say what? Okay, and finally, I can say yeah, and I hope it wasn't a question. Yeah, so during our communications as human, we have different ways to receive feedback from the others, to ask the others to repeat what they said. So here in communication networks, we need automatic repeat request or automatic repeat query, as during the transmission of packets lost during congestion. So we use transmission control protocol to make retransmit. Automatic repeat request provides a mechanism for this retransmission to ensure communication reliability. So automatic repeat request is the mechanism that the sender and the receiver will use to request retransmit of the packet. The packet may be suffer from lost, maybe delay. If the delay exceeds the time to live or the time out of the packet, so we will consider the packet as a lost packet. Okay, so in order to ensure that the receiver receives the data without any error in a complete way, in a correct way, we must use retransmit, automatic repeat request. Okay, so as you know, in transmission control protocol, when the transmitter detects a packet loss, it performs a form of automatic repeat request called fast retransmit. As we can see here, this is example for TCP Renault. In TCP Renault, we use one version of sliding window. So we start our congestion window with 5. So the sender will transmit 5 packets before receiving first acknowledgement. So here the sender sends 5 packets and it receives 5 acknowledgement. After that, in TCP Renault, it will increment the size of the congestion window by 1. So it will be 6, and it will send 6 packets and receive 6 acknowledgements. Okay, so the transmission is not correct, no errors. So I will increment my congestion window. It will be 7. I will send 7 packets and receive 7 acknowledgements. Okay, communication is good, no errors. So I will increment my congestion window. It will be 8. I will send 8 packets. I receive here loss, so I must decrement my congestion window by half to be 4. Okay, here we have a loss. So we must detect where is the loss and request from the sender to fix this loss, to retransmit what we are missing from the packets. How can we do it? through using automatic repeat request or automatic repeat query. This is clear for you? Okay. So as you can see here, we discussed this example. As you can see, if we have a loss, this loss, what is the reason for this loss? Okay, this congestion. What is the effect of congestion on the packet?
They get dropped.
Drop,
And
delay. So congestion has a great effect on the packets. It may cause packets to be dropped, lost, errors, for example, or to be delayed. So the time out of the packet exceeds the time out of the sender and as a sender and as a receiver. So we consider this packet as a lost one. Okay. So as your answer is correct, packet loss is due to congestion. And congestion, we can define congestion in terms of loss and delay. Okay, so this is the reason why we may have packet loss on our network. Okay, so automatic repeat request is needed because packets may be dropped or packets may have errors. Channel have different types of noise. This noise can cause errors in the transmitted bits of the packets. So if the receiver, your packet may reach to its destination, but when the destination make processing over this packet, it may discover that this packet contains some errors. So we will ask the sender to fix these errors. How to fix these errors? By retransmitting this packet again. Okay, so we need to transmit the packet that suffer from maybe dropped or maybe have errors. How can we detect errors? And we can ask this question in different ways. How can the destination detect that it received the first packet and after that receive the second packet and so on? So we receive what we receive. This is the wire between the transmitter and the receiver. What is the form of data transmitted of this wire, for example? I know this is a technique. I want to know what is the form of the data. Ones and zeros, binary. Okay, so you are sending 1 0 0 0 0 1 0 1 0 0 1 0, something like that. How can the receiver detect that? Oh, this is the first packet. This is another packet, and so on. Yes, it's a good idea. So in order to enable the destination to detect the start of each packet, we add 8 bits. These 8 bits are called flag. Flag of what? Flag of start of the packet. Okay, so these bits consist of 0, 0, 6, 1, 0. So when the receiver detect at the start of transmission 0, 6, 1, 0, oh, it is a new packet. And after that, it will receive the bits of this packet. After that, it receives 0, 610. It is a new packet. Okay, so at first, okay, we make the framing. Framing in the packet, if you remember, we have a packet consists of data, and here is a sequence number and source address and destination address. This is the segment and this is the bucket. If you remember, we add start of header and tail, and this is called frame. In the header, in the start of the bucket, we add additional bits, 8 bits. These 8 bits are called the flag to indicate the start of the bucket. Okay? What we do at the tailor or at the end of the bucket, we add additional bits for making error detection. So in data lake, we make framing by set labels for start and the end of the bucket. Error detection determine if an error occurred in this bucket or not through using the error detection techniques used in the end of the header. And at some applications, we can use data link to do error recovery. As we know, the error recovery or error correction is mainly done at which layer? What is the layer responsible for making error correction? We know error detection can be done at the data link layer. Which layer?
Physical layer?
No. Which layer that should take the decision to make error correction? Data link layer at some applications can take these decisions. Okay, these applications that require no delay, for example, such as real-time applications. So if we detect that we have error, okay, so we must send that we have error. We detect the error and we need a recovery, fast recovery. Okay, it's some applications. These real-time applications that is operated over IP addresses, over networks, such as if we are making video conferencing on IP network, something like that. If we can fix certain error, we can do it. Okay, so at these applications, we require from data link to ask for error recovery. But most of times, mainly this function is taken by the transport layer. The transport layer is the layer responsible for making error correction, taking the decision of making retransmit. So the transmission control protocol is one of the protocols operated in layer 4, transport layer. Okay, so remember this. Making error correction or error recovery is mainly done at the transport layer. Okay, this is the function of the transport layer to take the decision of retransmit. But at some times, for some applications that require minimum delay, these applications accept delay, but needs very minimum delay. We can do the error recovery or error correction at the data link layer. Okay, this is clear for you. So, in which layer transmission control protocol operate?
Is it normal or OSI? Transport.
In OSI.
OSI, it's the fourth layer.
What is the name of the fourth layer?
The transport layer.
Transport layer. Okay, remember this, as this is a tricky question in interviews. They will ask you which layer should take the decision of retransmit. So your answer, the error correction or error recovery is mainly operated in layer 4 through using transmission control protocol. But at some applications that require minimum delay, the data link layer may take the decision of retransmit to minimize the delay. Okay? Okay. So the data link layer make framing. Why we need to make framing? To add the start of the packet and the end of the packet. In the start of the packet, we will add additional 8 bits to indicate the start of the packet. If the receiver detects that it receives 0610, okay, this is a start of a packet. Okay, and in the end of the header of the frame, we add some techniques, some bits to discover, to make error detection. Okay, this error detection can help the data link to take error recovery, retransmit in applications that require minimum delay. This is clear for you? Okay. So as I told you, we will add 8-bit flag is used to indicate the start of the packet. So this is the content of our packet, and so we will add extra 8 bits as a flag to indicate the start of the packet. At the destination, when the receiver detects the start of the packet, it will remove this extra bit and make processing over the received packet. Okay, this is clear till now. Okay, so errors can occur in the transmitted data. The errors can be in the flag or can be in the transmitted of the actual bits of the packet. Okay, how can we detect errors? Actually, detection of errors is a very important topic in communication networks. Okay, and it is very important and useful for you to know how to detect errors. Okay, one way, and I think you have a previous knowledge about it, is using the parity check. Anyone here know something about what is the operation of the parity check?
Did you count like the number of ones or zeros that it's moving or on?
Yes. So we will count the number of ones in the transmitted data. Okay. So for example, if the number of ones is odd one, so we will add extra one, so the total number will be even. Okay, and we transmit these bits, and as the receiver we will check the number of ones. If it is even, so it's correct transmission. If it is odd, so we have an error. But what is the drawback of the parity check?
If it's still even, could it still not still be wrong? It's like, what if you lose 2 ones? Because like if you lose one, it'll go to on, but then if you lose another one, then it'll go back to even.
Yes, so it can't detect even numbers of errors. So for example, if we have a change in one bit, so this bit change it from 0 to 1 or 1 to 0, so we can detect that we have error here as the number of ones will be changed. But if we have 2 bits changed, so it may be difficult to detect this error. Another way to solve this problem is use horizontal and vertical parity check, is to divide your data into a matrix, and in each column and each row, you will add a parity check for this column and this row. But the processing of this process is very complex, and you will add many additional bits, so you will consume your resources. You are transmitting, wasting your resources of bits, additional bits that is not useful for your information that you want to transmit. Okay, so other techniques can be used, such as cyclic redundancy check. In CRC, in this technique, as I told you, we have additional bits, around 3 or 4 bits, and they make certain operation, mathematical operation or arithmetic operation over these bits, and transmit the result to the destination have the same bits and will do the same arithmetic operation or mathematical operation over these bits. And if the result is the same, this means that the bits are transmitted in a correct way. If we have different results, this means that there may errors in our communication chain. Okay, this is clear for you. So now we detect that we have error. Okay, through one of the used techniques, and all of these techniques are done in the data link layer. I focus on this point as this is very, very important point in communication network. The function of each layer on the OSI model is very important. You must focus on it, and you must know what is the function of each layer. Okay, as this is very, very important. Okay, so we can make error detection in data link layer through one of our techniques. We can add here in the tailor or in the end of the frame, we can add a single bit parity check. We can add a parity check matrix. We can add CRC, and the most common way used in error detection is the CRC. It has another name, maybe, yeah, frame checksum. Okay, so here we can use the most popular detection method is the CRC or frame checksum. They are the same, but the arithmetic operation are different. And frame checksum from the CRC. Okay, but the same concept is the same. Okay. Okay.
Sorry, I got a little confused there. Is it the data link layer that's always doing the error checking, or layer 4? Like
Error detecting.
yeah,
Data link.
data link layer.
Yeah. Layer 2. But the decision of retransmit is taken in layer 4.
Okay.
And again, can data link layer take decision of retransmit? Yes or no?
I'm gonna say yes.
Yes. Oh.
Yes.
I told you data link layer can take retransmit decision, and some applications that require minimum delay. Okay, that require minimum delay. Okay, as why we postpone the decision of error correction to transport layer. Can anyone tell me? Why? We already make error detection in data link layer 2. Why I have to wait to the processing of layer 3 and the processing of layer 4? If we are thinking as a router or as communication device, if I detect the error, I will send retransmit at the same time. Yeah, this is what we will do in real life. Yeah, but why we have to wait to layer 4?
Is it because layer 3 deals with like all the IP stuff, so you need to know where to send it back? You can get that information from layer 3.
Okay, this is a correct part of the correct answer. So we must wait to know the IP address. Okay, but
Therefore, like
why? Yeah. If I know the IP address, why I have to wait to layer 4? Okay.
layer 4 transport. So wouldn't that enable you to receive it?
I will give you a hint. Okay. In the transport layer, we add certain header. What is this header? What?
You're saying the flag before.
Yeah. Here our data, and in transport layer, we divided this data into segments. Okay, and we add in the transport layer header. What is this header called? What is the name of this header? What is the use of this header?
Sequence number?
Sequence number. So I have to wait to transport for 2. I have to wait to the processing of layer 3 to detect the source IP address and destination IP address. Okay. And I have to wait to the processing of layer 4 to know the sequence number. Okay. After I know the sequence number, I know which packet, what is the number of the packets that had error. Okay. So after waiting to that sequence number at the transport layer, I know now that this packet number 2 that has error, so I must send the request to retransmit packet 2. Okay, so this is why we must wait to the layer 4 process. Okay, so the retransmit decision is taken by layer 2 is sometimes maybe not accurate. Okay, but in order to take an accurate decision of resend or retransmit certain packet, I must wait to know its sequence number. Okay, so in data link, if we request to resend this packet, okay, actually we may suffer from a problem if the packets are arrived in unordered sequence. So data link can send retransmit in accurate way if we receive the packets in order way. So I receive 1, then 2, then 3. So if I detect the problem, if I detect a problem in packet number 2, in the second received packet, I will send please retransmit packet number 2. Okay, as I expect that the number of this packet is number 2, but I am not sure that this is the packet number 2 or not. Okay, but in order to take a correct decision, I must wait to the layer 4 processing. In layer 4 processing, we are able to know the sequence number. So we can take an accurate decision of please retransmit this packet. Please retransmit packet number 2. And I am sure that packet number 2 has errors. Okay, this is clear for you? So can anyone provide us with a summary of this process? So what happened? Yeah, okay.
I just wrote it down, so I'll do it. Layer 2 determines if there's an error or not.
Okay.
Okay,
So determine what is the meaning of determine if we have errors or not? Detect.
detect,
Yes.
or it detects if there's an error. Layer 3 breaks it down, finds the IP of where the messages came from.
Yes.
And layer 4 breaks it up, finds the sequence number of the bit of the packet that is like erroneous, and then goes and requests a resend.
Yes. This is a correct.
Wasn't big.
Perfect. Yeah. Okay. So you understand this sequence? Okay. Daniel. Okay, for you with you?
Yeah.
Clear?
Yeah.
Okay, perfect. So now you understand why we have to wait. As it is unlogic. Yeah. If I detect the error, I must send retransmit this error. But in communication network, we are working based on a layered model. So we must follow the rules of each layer. Okay. So now let's discuss the first technique, how you can request from the sender to retransmit a packet, which contains errors or delay or loss. Okay. Till now, I want to take your opinion about something. do you like the way that communication networks are operated? It's your opinion. So if you are a scientist, for example, are you satisfied about this layer structure and this way of operation?
No,
Why?
a lot of delays and errors all over the place.
But at the end of this delay, we are sure that we will receive the correct back at the end.
There's gotta be another way. That we don't know. I'm sure there's a way to improve our. We don't have a perfect system.
So, your opinion that the current techniques are not efficient
Could be more efficient.
in terms of delay.
Yeah.
But it is efficient in terms of receiving correct data.
Yeah.
Yeah. We can improve this more. Okay. Another opinion?
I like it. I think it's awesome.
And why?
It's just clever. Yeah, except my computer's internet is slow, so maybe not in my house.
So you are satisfied.
Yeah, I'm satisfied.
Any other opinions? But what about you?
It's separating them into specific layers like that. I can see why some people, or if people adhere strictly to how layers are built, then how it's going in the, or basically the way that technology is going, it defies those layers. It's combining a whole lot of stuff. And so there's two ways of thinking. There's one point of thinking where if you throw out this idea of having all these isolated layers, you can do things more efficiently and fast. But then you're sort of breaking tradition.
Yeah, so your opinion is that we need to merge some layers together.
Yeah, to look at them, to have individual layers, each responsible for their own thing, is, yeah, not efficient.
Okay, so do you remember that TCP over IP model?
Yeah. So that is, yeah, they've merged a whole lot later.
So in the commercial, TCP over IP model is the commercial model, layered model used in industry for the internet.
Yeah.
So the first idea, they merge some layers together. So in TCP over IP, we merge the application, presentation, and session layer in one layer called application. Okay, then we have transport. Okay, then we have network or internet, and they merge the last two layers, physical and data link layer, in one layer called network interface. Okay, so this is what is done in TCP over IP network. So we can merge some layers to operate together. But to be honest, okay, separating layers help us or enable us as engineers to detect where is the error in a fast way. Okay, so yeah, if we have a problem, for example, in the framing, so we know this is in data link layer problem. If we have a problem in IP addressing, okay, so we know it is layer 3 problem. If we have problem in sequence number, so we know it is layer 4 a problem. Okay, so but if we merge layers together, if we have, for example, if we merge the layer 3 and the layer 2 together, if we have a problem in addressing, we will do very further steps to understand or to know where is the error, as the data link layer header become very large, and I must make analysis for a very large header to understand where is the error, for example. So separating the network architecture into layers, small layers, help us to understand more the operation of the communication network and enable us to detect and solve the problems in the network in faster way. Okay, so every opinion has a trade-off relation between advantage and disadvantage. Okay, it's good to have this kind of discussion as maybe one of you become scientist and solve one of the communication networks problems in the future. Okay, so let's discuss now this first technique is stop and wait. From its name, what do you think? What is the operation of stop and wait? And wait. So we have sender. Actually, this is the simplest automatic repeat query technique. Okay, we have the sender and we have the receiver. The sender will transmit first packet and wait to receive acknowledgement. Receive acknowledgement and will transmit my second packet, stop, and wait for the third packet, and so on. So this is the simplest one. In this technique, sender will send the packets in the order they are received from higher layers. So we have in transport layer, we divided our data into segments. Segment 1, 2, 3, 4. So I will forward at first bucket 1, after that bucket 2, after that bucket 3, and so on. So I will send my data in order way, and the receiver also will receive the data in the same order. Okay, so in this case, if the data link layer takes a decision of retransmit, will be accurate or not?
Yes.
Why?
Because it stopped and waited for the other parts.
Okay, so I will receive the first packet. So I know this is the first packet and send acknowledgement. After that, I expect to receive the second packet. Okay. If there is error, if I detect error in this packet, actually in the data link layer, I don't know the number of this packet, but I am sure that this is the second packet as we are using stop and wait technique. So this must be the packet number 2. Okay, so here one of the applications that we can use data link layer to take the decision of error recovery. Okay, but in other techniques we can't use the error. We can't use data link to make error recovery. This is clear for you? Understand? Okay, so the sender sends a packet and waits for an acknowledgement. Okay, the receiver sends packets in the right order. This is why we can take error recovery decision in data link layer in this technique. So as a receiver, know that the packet will be received in their right order. Okay, the receiver will decode the packet. If no error is detected, the receiver will send acknowledgement. If an error is detected, the receiver will send no acknowledgement. Okay, so after the receiver send no acknowledgement, this means that for the sender that this packet have error. Okay, you don't understand no acknowledgement?
Just clarify that. So in this case, it's sending a message back to the sender that says, I'm not acknowledging this.
Yes.
Okay, so it's not just not sending an acknowledgement.
Actually, the operation is done in this way. We have sender and we have receiver. Okay. The sender will transmit a packet. We have several possibilities here. The receiver will process this packet. It's okay, no errors. I received this packet in a correct way. I will reply with acknowledgement. Okay. The second scenario that the transmitter and receiver. The transmitter will send the packet, but due to some noise in the channel, may be this packet not received at the receiver. So the receiver doesn't know anything about this packet. So in this case, the receiver will not send anything to the destination, to the sender, as actually I don't know anything about this packet. Okay, so in this case, the transmitter have timeout. I expect to receive acknowledgement within 5 seconds. 1, 2, 3, 4, 5. Oh, no acknowledgement received, so the packet is lost. So I must retransmit it again. At the end of the timeout, the transmitter will have to retransmit again. If this packet is received in a correct way with no errors, the receiver will reply with acknowledgement. And note that this acknowledgement, I must receive acknowledgement within the timeout. The third scenario, the transmitter and the receiver. The receiver will send a packet, and the packet is received in a correct way. Okay, and okay, let's send acknowledgement, and the receiver has timeout, but the timeout is ended before receiving an acknowledgement. Okay, so the receiver will send an acknowledgement, but the timeout is ended before we receive the acknowledgement. What will the sender do? Send it again. Okay, as the timeout is over, so we will send it again. I have this bucket 1 and this acknowledgement to bucket 1. So we receive here the acknowledgement after the timeout is over. So we take the decision of retransmit bucket 1. Okay, this is the third scenario. What is the fourth scenario? We send a packet, and this packet is received at the destination. But during the processing of this packet at the destination detects that this packet contains errors. So the packet is already received at the destination, and the destination or the receiver make processing for this packet. And during this processing, we detect that we have errors. Okay, so the destination will send to the transmitter, okay, no acknowledgement, which means that your packet is received, okay, is transmitted, and I already received your packet, but it contains errors. So please retransmit it again. So once the transmitter receives no acknowledgement, okay, it will retransmit packet 1 again. This is clear for you? These are all of the scenarios in stop and wait technique. Okay.
For the scenario where the sender sends the same packet twice, the bottom left corner.
We have this scenario and this scenario.
Yeah, that one.
Okay.
Will the receiver see that the sequence number is the same, the two packets is received, and then just think, oh, okay, sure, it's just the same packet. We'll think, oh, this is packet 2. Even though it's the same packet.
Okay. So this is a good question. Your question is, we already sent packet 1, and the Bucket 1 was received in a correct way in the destination, and the destination already sent or forwarded acknowledgement, but this acknowledgement due to some congestion in your network was delayed. Okay, so this acknowledgement was delayed due to congestion in the network. Okay, so the sender will retransmit this packet again to the destination. Okay, so based on the stop and wait technique, the receiver expect that this is the second packet, not the first packet. This is your question. Yeah. If this packet is received in a correct way and it doesn't contain any errors, the receiver will make processing and will detect that no, this is the first packet. As we will go through data link layer, remove the frame header and tailor, go to the network layer, we remove the IP addresses, go to the transport layer, remove the sequence number, and from the sequence number, we will detect, oh, this is the first packet again. Oh, maybe my acknowledgement was delayed in the network. Okay, this is the first scenario. The second scenario, maybe this packet received and it contains error. Okay, for example, yeah, so I can transmit my first packet in one time, and after that retransmit it again, and due to some noise in the channel, we receive it in it contains some errors. Yes. Okay. So in this case, the receiver will detect that this error, this packet contains errors. If the error detection, if error correction is done at the data link layer, so we will have a problem in the network. Okay. So it will request from the sender to retransmit packet 2. Okay, as it expects that it is now packet 2. Yeah, okay. So this is why I told you taking the error recovery decision as a data link is not accurate and may cause problems. Okay, so mainly the error recovery decision must be taken in the layer 4 transport layer to be sure that from the sequence number, I will request to retransmit certain packet, and this packet I must be sure from the number of this packet. Okay, so here in this case, the receiver will process these packets and will know this is packet one again. If it is received in a correct way, this packet 1 again. Okay, the receiver will detect that there is a delay in the network, so its acknowledgement may be received after the timeout. Okay, if there is error in the received packet 1, the receiver, based on where is the error detection is error recovery is taken. If the error recovery is taken in layer 4, we will not have error in the channel in the communication, and the receiver will detect that the error in packet 1 and will request from the sender to retransmit packet 1 again. Okay, even it has packet one time. Okay, as it will overwrite this packet 1 over the previous received packet 1. Okay, it will overwrite it. Okay, so it will request from the sender to retransmit packet 1 again. If the error recovery is taken at data link layer, this means that we will have a problem in this network. So the receiver will ask the transmitter to retransmit packet 2, but I didn't transmit packet 2. So the sender will know this problem and will detect this problem and will transmit packet 1 again. Okay, so this is summary. Actually, we are done. We can have a revision on this scenario on the start of our coming lecture and complete the techniques of the automatic repeat request techniques used in communication. Okay, this is clear for you? Okay. Have a nice day.
Thank you. You too.
We actually could send a no acknowledgement instead of just waiting for the timeout.
Which scenario? This one?
Yeah, this one.
This one.
We actually do send a no acknowledgement instead of just waiting for the timeout to resend.
Yeah.
Okay.
So here, but we received the no acknowledgement.
Yeah.
Before the timeout.
Yeah.
is over.
No, I was curious if it wasn't just, you just don't send, since you already have a timeout, you just don't send the no acknowledgement and just. wait for the
Yeah,
timeout.
if I don't send no acknowledgement, yeah, I will retransmit that one. But the reason that we need to have no acknowledgement to let the transmitter know that the channel is noisy now.
Yeah.
We have errors in the channel, so be careful. Okay. So this enables the transmitter to know why I have to retransmit it again. Okay. If we don't receive acknowledgement, this means that
There's some issue in the.
some issue in the communication network, such as delay congestion, for example. Okay. But if we receive
We
no
send that
acknowledgement, this means that we have lots of noise. The channel is noisy, so we have error in the transmitted bits.
Okay.
Uh,